Okay, so let's look at the last example problem, another lead code problem. So we are given an array and we want to compute the number of triple indices ijk so that I is less than j, and we want the ijk to satisfy the property that if we XOR everything from AI I to j minus 1, and we XOR everything from j to k, then they are equal. So A and B are equal. So for example, given this thing, there are 4 triples, so 0, 1, 2. That means the first 3, because if we have 2 by itself, and then 3 and 1 XOR together give us 2, so that equals 2. And also, if we have 2 and 3 XOR together, that gives us 1, and then that equals this 1. So these are these 2, and then 2, 3, 4. These 3 also satisfy the condition. If 6 XOR 7 give us 1, and that equals 1, and also 1 XOR 6 give us 7 equals 7. So if you want, you can pause the video and think about it a little bit. So here there's I guess one clever insight based on the property XOR is when A is equals B, then that basically means that their XOR is 0. So that's the equivalent condition. A equals B if and only if A XOR B equals 0. And then that means what we want is from I to K XORed all together, we get 0. And so long as that occurs, then J can be any value between I and K. So J can be any value from I plus 1 to K. So really what we need to find are the ranges that XOR together to be 0. So and let's look at the parameter size. So the array length is less than 300. So then what that means is quadratic is very comfortable. In fact, probably cubic would be fine if it's with a time limit, but we want to use as efficient algorithm as we can. So we will do quadratic if we can avoid the cubic. So the 3 unknowns, the trivial algorithm, brute force algorithm will be actually I guess if the really brute force can be quadratic in time, you try every possible ijk value, and then you compute this, and then you check, that's actually quadratic. Not quadratic, quartic, so it's n to the 4. So by using this prefix XOR value array idea of the previous problem, we can solve this in quadratic time, because the question boils down to finding subrange that are XOR to 0. So we so we compute this at the previous question, and then we loop over all possible value of I and K, and then we check whether the range XOR equals 0, which is basically the same condition here. And if that is true, then we know J can be chosen as any value between I plus 1 and K inclusive. So then that means there's K minus I choices. So then we just return that. So yeah, I think this one has been submitted before, so it should be correct. Okay. Yeah, there are probably ways to do it without the prefix sum array, and then you maybe taking longer time. And there may even be an algorithm that doesn't use that much, and it's still quadratic time. Okay, so that's the end of topic 8.